Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with episode number 16 in our incredible new tutorial series where you're going to learn artificial intelligence or you're going to die trying. What I'm going to need you to do is pour yourself a nice large glass of iced coffee. That is straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's just jump right in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to do facial recognition in OpenCV. Now, we dipped our toe in this particular pool of AI water last week when we learned how to do face detection. With face detection, we analyze a frame that we grab from the webcam and we find faces. Any faces and all faces, we find them and box them. What we're going to do today is to take that up to the next level, take it to that next level by not just finding the faces, but identifying the faces. So we are going to have to train OpenCV to recognize certain people, and then in a frame, we can look for those people and then box them and label them if we find them. So that is going to be a pretty cool thing. Sorry, got a junk Skype call coming in, but I think I got it canceled there. All right, sorry about that. But what we're going to do is we're going to learn how to train OpenCV to recognize faces and then to find faces and identify the ones that they have been trained for. So what I will do is I will switch out of your way over here and I will move out of your way. And then what we are going to do is we are going to fire up the most excellent Visual Studio Code. And there's a couple of bookkeeping things that we're going to need to do to get started. One thing is it's going to be a lot easier for me to teach and a lot easier for you to learn if we're working on the same group of images. Now, after I teach you how to do it on this set of images, then you can use whichever images you want. But let's start out your first time. Let's use the same set of images. So let me show you how to find those images. What we will do is we will go to github.com. That's github.com. And then you're going to do a slash github.com slash. Then you're going to go to my GitHub page, which is MCWHORPJ. PJ is in Paul Jackson. MCWHORPJ. Click enter, and then you will, with a little luck, come to my page here. And you can see that there is a repository called Demo Images. I will need you to click on Demo Images. And then you are brought to this page, and you can see I have two folders, a folder of known images and a folder of unknown images. Here at this page, you'll come over to Code, and you will come down and say Download Zip. So you're going to get a zipped file of those two folders, and you can see down here that we are downloading. Take a little shot of coffee here while we're waiting. And boom, it is downloaded. Now understand this is a compressed folder at this point. So we're going to open that folder, which is the Demo Images Master. And inside of it, you see another folder, Demo Images Master. Now we're going to open that one. Okay. And then we're going to leave this open. And we're going to come over to Visual Studio Code, and we're going to create in our Python working folder, we're going to create a new folder, and we're going to call it Demo Images. And so remember, it was not a file I created, it was a folder Demo Images. Now the darn thing is I cannot drag and drop into this through Visual Studio Code or can't paste into it. You got to go back to your real folder system to get those images over. So we are going to right mouse click and we're going to say Reveal in File Explorer. And this should open the folder in the File Explorer. And there it is. And you can see what we wanted here was demo images inside of that Python working folder. So this is our destination folder, and this is our source folder. So we're going to get those two folders, known and unknown, and we're going to drag them over here to demo images. All right, that looks successful. Now let's just make sure it works by coming back to Visual Studio Code. If we look inside of demo images, we have known images and we have unknown images. So we got a group of JPEGs and a group of JPEGs. All right. So understand that for this demonstration, I am going to use mainly political figures. Why? Because their images are not copyrighted and they have no expectation of privacy, or they have no publicity rights. And so we can use these images without fear of running afoul of privacy rights, publicity rights, copyrights, trademarks, that sort of stuff. So a legally safe set of images to use. I neither endorse nor condemn anyone here, and I've got people from both sides of the political party. So just understand these are images. Let's not use this as an opportunity to turn this into some sort of political discussion. Even-handed all the way across here, and I will make no commentary, positive or negative, about any of the people involved, and hope you all will do the same thing. Okay, so we've got our images. Now we're going to have to do a little bit of bookkeeping to install a couple of libraries. And so we're going to come down here to our terminal view down at the bottom, our terminal. And what we're going to do is we're going to activate the virtual environment that we have our OpenCV version of Python in. Now, if you have been working with me throughout these lessons, we have been using the virtual environment PyAI 3.6, and we've been using Python version 3.6.6 inside of that, and that's been the Python interpreter we've been using, and everything we've been doing is associated with that. If you're just jumping into this lesson, the thing I would say is just make sure that you install these libraries in whatever Python version you intend, whatever Python interpreter you intend to use for all your AI type of work. I hope that makes sense. If it doesn't and you're a little rusty, go back to lesson number 3 in this playlist, in this series of lessons, and I talk about virtual environments and getting your Python interpreter and environment set up for this series of lessons. But I have talked enough about that, so let's just jump right in and let's activate that virtual environment. So I'm going to say PyAI 3.6, and then you go to Scripts, and then you say Activate. Let me make sure that you can see that. I guess I better get out of your way a little bit more. Okay. PyAI 3.6 / scripts with an uppercase S and then / activate. And let's hope this works. So we're going to come over here and boom, we are in our virtual environment PyAI 3.6. Let's just make sure if we type Python, you can see that we are on Python version 3.6.6. So the world is indeed as it should be. World is in proper order. So that is good. Now we need to install a couple of libraries. There is a helper library that will allow us to compile and install some of the things we are going to need, and it is called CMake. So we are going to need to do a pip install C, uppercase C, M-A-K-E, uppercase C, lowercase M-A-K-E, CMake. So we're going to do a pip install of CMake. We are collecting it. And guys, some of these libraries, depending on your internet speed, are going to take a few minutes to download and install. I hate to stop and start the video, and so we can just sit here and wait together while I'm waiting to download. I'm sure you're probably waiting to download as well, but we are downloading CMake, and then we will install it, and then we will move on to the next library. Good news is there's only 2 libraries that we are going to have to install, and the other good news is we install both of them with pip, and so it's really easy to get this thing up and configured like we want. We will be recognizing faces before this night is over, or for you before this morning is over. Okay, so we got the CMake downloaded, and it is installing it now. It does make us wait for a minute or two. You know, I really hate being postage stamp size, so I'm going to come back up here. So I I think this is really a cool lesson, and I'm going to show you enough where you can really go in and start training this to recognize your POIs, your persons of interest. Okay, so you can train it to recognize whoever your particular persons of interest are. Okay, it looks like we had a successful install. Now the next thing we are going to do is install face recognition. So we are going to do pip, if I can come back over here. And you guys can't see that at all, can you? I'm going to have to go back to postage stamp size. We're going to do pip, we are going to do pip install face underscore recognition. Face recognition. And even being a little munchkin, you still can't see that. Maybe if I come over here. Okay, now you can see it if I just turn off the File Explorer. So pip install face underscore recognition. Wait for it. I hate it when you guys hit return before I'm done. And then you're going to say equal 1.2.3. What does this mean? Right now, the most recent version of face recognition is 1.2.3. But if you're taking this class like 3 months from now, the latest might be a different version. So if you type it in this way, face recognition equal 1.2.3, you will be guaranteed that you are running on the same version of the library that I am. And therefore, if you do what I do, you will get the result that I get. But if we're on different, versions of our software, we can get unexpected results. So let's go ahead and hit enter now, and we are collecting face recognition 1.2.3. Looks like it is downloading, and so that looks happy. Always glad to see that. And then this does take a minute or two to install, because it is also installing the dependencies, and so it's getting in there the dependencies like I think there's some software called Pillow that helps you interact with images, and some various support libraries that it will be installing as well. So we are moving right along here. I have to say that it is evening time here, and in the evening I do not have the world's fastest internet connection. I'm going to stop being munchkin size there. Okay, this is not too bad though. And we've got that one. Collecting clicks, that went fast. Okay, now dlib is another library that is sort of an artificial intelligence library, so we are getting dlib. And now Pillow is probably about the last one that we're going to have to get, so we'll be there pretty soon. This looks pretty good. Now it's doing setup, install, and now it's actually installing dlib, which will take a couple of minutes. So what we're going to do is, with this group of images that I've given you, what we're going to do is, if we come over here, the known images, we're going to train on the known images, and then we are going to look at the unknown images, and then we're going to try to identify people we know in the unknown images. So the thing is, you don't want to use the data set that you train on to then test on. You train on one data set and then you test on another data set. And I think this dlib is the last one. So we're going to be coding here in about 2 minutes. So never fear, we will be coding in about 2 minutes. I'll go ahead and do a little Windows management here. All right, done. Okay, and we are ready to go. So we are going to come in here, and we are going to come back to our Python folder. And in our Python folder, I believe that this is going to be program number 23. So we will click the plus, and then we will say OpenCV-23.py. The .py is kind of important. We'll hit enter, and boom, a fresh new Python program just waiting to be written. Okay, I'm going to go ahead and clear out this down here just to kind of clear that mess up a little bit, and then I might as well deactivate that virtual environment. And then I am looking down here, and I need to select the right virtual environment. So I am on Pi AI 3.6. So make sure that you are in your Pi AI 3.6 virtual environment, and now we are ready to go. What are we going to do? Well, you can imagine we're going to import CV2 as always. Now we are also going to import face recognition. And as you can imagine, I don't want to spend the rest of the evening typing out facial recognition, so I'm going to say import that as uppercase FR. So now if we want to use facial recognition, all we got to do is type in FR. Okay, we will be labeling pictures, and so let's just do a little bookkeeping and go ahead and set up a font so you won't have to do this over and over. The font is going to be equal to CV2 dot font underscore, and I think I like the Hershey Simplex, just the font Hershey Simplex like that. That is a pretty simple one, works well for my purposes. All right, what we're going to do now is we are going to load up an image. We're going to load up a known image, and the known image that we are going to load up is we are going to load up the Donald. And the easiest way to do that is come over here, point at the file, we're going to right mouse click, and we are going to say copy path. Okay, so now we've got the path to that file. Now to load it, what we are going to do is we're going to call it Don Face, because this is going to have Donald Trump's face in it. So it's going to be Don Face is equal to, that's going to be the image name, FR, that's library.load image file. So we're going to load the image file. What image file are we going to load? I'm going to put a quote there, and then I'm going to paste that path, and we're going to load that whole path, and then we're going to load the image of the Donald. Now what we know is we know that these darn slashes are a holdover from the 1995 disk operating system, DOS, and for it to work in OpenCV, we have to make it the other direction. We got to make it the /. And so we'll come in and we will make all of these /. All right, that looks pretty good. I think I'm going to go ahead and run this just to make sure that it will run. Now it doesn't do anything, but it didn't crash, and so that means the library's loaded, things are talking, and it found that image. Okay, so we did Don's face. Okay, now what we can do is let's see if we can find a face in that image. So we're just going to look and say, is there a face in that image? So what I'm going to do is I'm going to say face location, face lock is equal to fr dot face locations. So I'm going to find the face locations. Where am I going to look for it? I'm going to look for it in Don Face in that image. Okay, and then I'm just going to print it. Print face location. So let's see if it finds a face in there. All right. So we're going to run this. Okay, and boom, it found a face. And this is the darndest thing what these numbers mean. Like you would think that it would be kind of like XY of the upper left corner and XY of the lower right corner and sort of the corners of the box that would be around the face that it found. But no, what they decided to do is the first number is top, the second number is right, the third number is bottom, and the fourth number is left. And so that is kind of a mess. The other thing I want you to see is that is kind of annoying is that it put those four numbers in an array inside of an array. And so what it's thinking is, well, I might find four faces, so I need to have an array of arrays. And then that kind of causes a problem, because if I just want these numbers, they're kind of deeply buried in there, and you start getting array shape type errors. And let me just kind of show you this here. Let me just kind of fire up Python and just kind of show you what I'm talking about, because this face recognizer does this, and I want you to understand what I'm doing when I'm coding. I don't want you to just do it and not understand it. If you're going to code on your own, you've got to understand this. So let's just say that I have X is equal to an array of 1, 2, 3, 4, like that. Okay, and now I can print X. Okay, look at that. It is the array 1, 2, 3, 4. Well, what if those were positions, and what if I had two boxes? Well, then I could say x is equal to open, and then open the first box, 1, 2, 3, 4, close the first box, then comma, and then open the second box, 5, 6, 7, 8. Okay, and now close that. Now I have an array of arrays. So if I say print x, boom, it gives me the array of arrays, or I could say print the first one, which would be x0, and I get just an array, okay? Or I could print x of 1 and I get just an array. All right, but this is what, and that's great, right? Because I could pick the first array, the second array, the third array. That's great, right? But this is what happens. What if I have an image and it has one face in it and it returns an array of arrays? Well, instead of having two arrays, it returns an array of one array. Okay, do you see what the problem is? I've got double brackets. So now if I say print x, I have an array inside of an array, and it's an array of only one array. And so you could look at it as I have an extra set of brackets around here that are going to cause me nightmares. And so one thing that I could do is I could just say print, or I could say y is equal to x of 0, like that. Even though there's just one, I'm going to do that. And now if I say print y, I have the array. So I have to go in, I have to get that array out of the outside array, if that makes sense. So you see, x is an array inside of an array, but y is just the array. And so you're going to see me, as I'm coding, putting an open bracket, close bracket, 0. That's to get the array I want out of that extraneous set of external brackets. I hope that makes sense. If it doesn't, go back and watch this again, because you're going to be seeing me do this quite a bit. And so if we go back and run the program, what you got to remember is, I'll quit here. What you got to remember is, when I run the program, okay, you can see that the array that has the position in it is inside of this other array. And so if you really wanted to work with this, you would probably need to do something like this. And now watch, when I do this, it should take those outside parentheses off. Okay, so you see there you've got just the array. But for this case, I need to keep it in that original data structure, and you'll see why in a minute. But I now know where the face location is. Okay, I know where the face location is. And so let's just go ahead and see if I can, let's see if I can print that. So I think probably in this case I am going to go ahead and put a 0 there like that, and then I'm going to print face location, and then I am going to do a cv2.im show. And what am I going to show? I'm going to show Don face, and then where am I going to show it, in which window? It'll be my window like that, and now I should get a quick view of that, and then I just need to do a cv2.wait key, and I'll have it wait 5 seconds, 5,000 milliseconds, and then it'll go away. The program will quit. And I think, why don't we also, besides showing his face, let's go ahead and box his face. So we're going to do a cv2.rectangle, I want the rectangle on Don face, okay. And then where do I want the rectangle? You know, I better go in and I better kind of get those positions out of that array, okay. And remember, I have just an array now. So what I can do is I can just say, remember I said, what order does it return it to me in? The top, and then the right, and then the bottom, and then the left, and say that is equal to face location. And now I should have the top, the right, the bottom, the left. Now, I've got to tell it where I want this rectangle, and it wants the upper left corner, and it wants X first, so it's going to be left, that's the X value, and top, so that's the top left, and then it wants the bottom right, so this will be right, X first, and bottom. Okay, and now I think we need to give it a color, so we're going to say 255, 0, 0 should be blue, and then we need to give it a line thickness. We'll give it a thickness of 3. So now let's see what happens here. So we find a face. We don't know that we just know that we're looking for a face. We find a face and we're going to box it. Let's see if we can do that much. Half boom. We have an unexpected result in Mr. Trump is blue. Tell me what happened. Why did Donald Trump become a Smurf? The reason he became a Smurf is the rest of the world, including JPEG images that we load and including face recognition, work in the RGB color space. But OpenCV works in the what? The BGR color space. So what you've got to see is if we are doing commands that are face recognition commands, FR commands, we need the image in the RGB space, which it is. But then if we're going to show it in OpenCV, it's got to be the BGR space. So what we're going to do is we're going to come in here and we're going to go ahead and create a new image, Don face in BGR is equal to cv2.cvt color. And then what do we want to convert? Well, we want Don face. And then, man, you guys that hate Donald Trump are really sick of this. Don't worry, I'm going to do Nancy Pelosi next. Okay, so we can flip-flop about who you hate and who you like next. Okay, so Don face BGR, we've got Don face, and then what do we want to do? cv2.color. And what we want to do is we're in RGB and we want to go to BGR. And then we're going to show Don face BGR. And if I am thinking right, this should work. Okay, so he's the right color and he's got a box around his face. So we now can find, using facial recognition, we can find a face. All right, so that's the first thing we wanted to do, was we wanted to find a face. Okay, so now what we need to do is we need to encode that face. Okay, we need to encode that face. So now we have loaded the image. We have found his face, and now what we are going to do is we are going to encode his face. So it's going to be now Don face encode. We're going to create a code of his face. We're going to learn his face. And we do that with fr.face encoding. So we're going to encode his face. How do we encode his face? Well, what do we look at? We look at Don face. We look at that image. And remember, this is the RGB image. We look at the RGB because FR works in the RGB. Now, this thing is thinking I might find lots of faces to encode. So what is it going to return? An array of encodings, an array of arrays. Well, we know we're training, so we know there's only going to be one there, but yet we still have to pull that array out of the outside array, and we do that by what? Taking the 0th element. And now that will get us a single array. That single array will be the encoding of the Donald's face. All right, so now we've encoded that. Now you know what we want to do is we want to do this whole thing again. Okay, and I think at this point, I'm not going to do the showing the images, all that stuff I'm not going to do anymore. Okay, so now what I've simply done here is just encoded Donald's face. And so I'm going to copy that, Control-C, and now I'm going to come here and I am going to encode what? Nancy face. So I load Nancy face, so I've got to give it the right file name. And here it is, Nancy space Pelosi.jpg. And so I will just come over here and change it to Nancy Pelosi .jpg, and then the face location for her will again be the face locations of Nancy face, and then this is going to be, we're going to encode her Nancy face encode, and what would we encode? We would encode Nancy face. Okay, so what are we doing here? We could get an array of encodings, and therefore we want just the one, so we say element 0. So now we should actually have both Nancy's face encoded, and we should have Dawn's face encoded. I'm not showing her picture because I don't need to, because we know that that code is working. We know we can do that, so I don't need to keep verifying that I know how to do that. All right, now we've trained on how many faces? We've trained on 2 faces. If you wanted to, you could come over here and you could train on all of these faces. But now I have to kind of create an array of all the people that I know. So what I'm going to do is I'm going to say that I have, what am I going to call this? My known encodings. My known encodings. These are the people I know, and it's going to be an array. Now, what's one that I know? Well, I have Dawn face encode. Dawn face encode is an array that has his face encoded. And then Nancy face encode, like that. All right. So my known encodings are the array Dawn face encode and the array Nancy face encode. So there's 2 people that I know. You could just copy and paste, and you could learn all these other people as well. But when you do that, they all need to go in your known encodings. Now you got to do a little bookkeeping here, and you got to keep track of who is who. So I need to create a second array of their names, and the order has to be the same. So who is the first person's name? Donald Trump. And then who is the second person's name? Second person's name is Nancy Pelosi, like that, in single quotes. Okay, so you see I've got 2 arrays. The first array has all the training data, all the encodings, and the second array has the corresponding names in the same order. All right, so now my model is trained. Okay, my model is trained. So now I'm going to load an unknown face. So I'm going to say unknown face. I'm going to load an unknown face. So we're going to come over here to the unknown folder. I'm going to come down to this one, right mouse click, say copy path. And then I'm going to say unknown face is equal to fr.load. And who am I going to load? I'm going to load that unknown face. And I'm going to have to go in with this laborious changing all of these things to forward slashes. I didn't want to copy and paste because this one's in a different folder. So there's just this unknown U3. That's all we know is it's an unknown picture. We're going to see if we can find anybody that we know in it. Well, that is unknown face. We better go ahead because we're going to want to eventually display this. So we're going to go ahead and make our unknown face BGR. We're not going to work with this one, but we're going to have it handy for when we need it. So that's going to be equal to cv2.cvt color. And then we're going to do the conversion on unknown face. And then it's going to be cv2.color. And this is going to be what? RGB to BGR. So we'll have that if we need it later. It's better to have it and not use it than need it and it not be there. So now we have got that done. So now what do we want to do? We want to see if we can recognize who is in this unknown face. And so what we need to do first of all is there could be a lot of faces in this picture, unknown 3, there could be 20 people in there. So we need to find the locations of their face. So we're going to say face locations. plural. So this is going to be an array of arrays, and each array is going to have the position of a person's face. So face locations, plural, is going to be equal to FR dot face locations. And then where do I want to find the face locations? In the unknown face. Okay, so known encodings are the encodings of the people that we know. Okay, face locations looks at my unknown face, my unknown face image, and it's going to find all the faces in that picture wherever they are. And so this is plural, face locations, because there could be more than one. Now I need to encode that. So I'm going to say unknown encodings, plural. Why? Because it's going to encode every face that it finds. Okay, it's going to encode every face that it finds. And so we're going to do an FR, and then what do we want to do? We want to face encodings, just like we did before. What do we want to do that on? On unknown face. Okay, and we got to tell it where the faces are. Well, that's face locations. So it's going to take my unknown, get that C out of there, unknown, my image unknown face. It is going to go to the different face locations, and then in the array unknown encodings, it is going to have the encodings of all the faces it finds. The encodings of all the faces it finds. Does that make sense? Okay. Now, if I want to actually identify, so I've got the people I know, they're encoded. I've got this unknown picture. All the unknown people in the picture have been encoded. Now I have to compare the unknown faces with the known faces. So what do I need to do? I need to step through the faces in the unknown image. So how would I do that? Well, I would step through, I want to step through what? Well, I want to step through face locations, right, where the faces are, and at the same time, I want to step through the encodings. So face location, and then the next array has a encoding. Next face location, next encoding. Next face location, next encoding. So they are two coupled arrays. The first one has all the encodings. The second one has all the face locations, and they sort of line up. The first goes with the first, the second with the second, the third with the third. So I want to step through face locations, but I also want to step through the unknown encodings, right? And so for each face location, there is going to be a corresponding encoding, okay? But what I want to do is, this is going to be face location singular is going to step through face locations, and unknown encoding singular is going to step through unknown encodings plural, okay? So for face location and unknown encodings in what? Face locations plural and unknown encoding plural. How come it doesn't like that? How did I misspell that? Unknown, missing an N. All right, now it's happy. Now, if you're going to step through these two, there's one other little trick you have to do that you normally don't do. You've got to tell it that you're stepping through them by saying zip. And this is just saying, when you put the zip there, as we go through, face location is going to step through face locations. At the same time, unknown encoding is going to step through unknown encodings. Okay, so we're stepping through two arrays simultaneously. All right, now the first thing we better do is unwind that face location. So you're going to say top and then we're going to say right, and then we're going to say bottom, and then we're going to say left, and we're going to get that from face location. We don't need to put the 0 because when we're stepping through there, we're already grabbing it out of the major array, the outside array, so we don't have those extra parentheses. We don't have that extra bracket in there. So all we got to do is just say face location like that. We might as well go ahead and just print face location, just so that might help us debug a little bit. We're going to go ahead and print it out. And then I think what we will do is, I think we will go ahead and let's build a rectangle. So we know where the face is. Let's build a rectangle on it. So we're going to say CV2 dot rectangle. And what do we want to put the rectangle on? We want to put it on unknown face, and then remember it is BGR, like that. How come it doesn't know? Oh, darn it. I didn't put that N in there again, up there. I hope you guys saw that. Unknown face BGR. Now it is happy. So we're going to put a rectangle there. And then where are we going to put the rectangle? Well, it is going to be left, comma, top, because it wants the X first and left is the X. And then it's going to go to right, comma, bottom. And then we're going to need to give it a color. So we are going to say, let's make it blue. So this is going to be 255, 0, 0. And then let's give it a line width of 3 there. Can you see that? Okay, now you can see it. All right, so that will put the rectangle there. And then all we're doing now is just boxing known faces. We haven't figured out who's who yet. And so one thing that we need to do is, in case you don't find anybody, you still got to give them a name. So if we don't find anybody, we're just going to say the name is unknown person. Okay, unknown person. Now we are going to show. I'm just going to go ahead and show cv2.im. No, I'm not. I'm not going to slow us down with that. So what I'm going to do is I'm now going to see if I can find matches. Okay, so I'm going to see if I can find matches. All right. So matches is going to be equal to fr.compare faces. All right, I'm going to compare faces. Now, what is my library? Everything that I know, all the things I know are my known encodings. Okay, remember that was all my training up here, my known encodings. It's everybody I know. It's all the encodings that I know. So it's this long list of people I know. So I'm going to be looking in known encodings, and I'm going to see if any of those match my unknown encoding singular. Okay, so my unknown encodings plural are the encodings of every face in my unknown image. And I'm going to step through them one at a time, and then they are going to become the singular, the unknown encoding of face 1, the unknown encoding of face 2, the unknown encoding of face 3. So here at unknown encoding, I am just on one picture, one face in that picture. All right. And so what it's going to look for is it's going to look for matches. And I've got one encoding and I've got a list of encoding. So if this matches the first one, it'll be true. And then if it doesn't, false, 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 false. Or if this one matches the third in my training data, it would be false, false, true, false, false. Okay, so you'll get a true when this matches something in this list. And so let's go ahead and let's just print out matches. Print matches like that. Okay, so let's look at this. Let's run this thing and see what happens. I think I should actually kind of see something here. I mean, I won't get a picture, but I should kind of learn something. Ooh, face recognition has no. That was a long time ago I made that mistake. What? Oh, load image file. I hope you guys saw that. Load image file. That should fix that. Okay. Now you're going to be watching down here. Okay. Don face BGR is not. Oh, yeah. We did that. We got rid of that. I am sure that was just from our earlier kind of demo. So this time I think it should really run. Okay. Now this is kind of interesting. So it looks like it found how many faces in the unknown image. It found 2. Okay, now it is going to step through those 2 faces. Now the first face that it found, it said that it is false, meaning it is not Donald Trump, and then it is true, meaning it is Nancy Pelosi. And then it goes through the for loop a second time for the next face, and it says true. It was a match with the what? It was a match with the Don face encode, and it was a what? A false for the Nancy face encode. So what does this mean? This means that that unknown 3 has 2 faces. The first face that it looked at and recognized was Nancy Pelosi. And then it found and it identified and matched Donald Trump. Okay, so you can just kind of see that if you had 3, it would step through it 3 times. If there were 3 faces in the unknown image, it would step through this 3 times. Okay, but we want something a little bit snazzier than that, I would say. So what we've got is we've got our matches, and we say, well, first of all, I'll leave that. Does anything match? Because it could be that it's a picture of your Aunt Nettie and there is no Donald Trump and there is no Nancy Pelosi in the picture. So the first thing you want to do is say if there are any trues, if there are any true in matches. So if any of the things in matches are true, then you're going to go into this for loop. And then what you want to do is, oops, one of them is true. Well, which one? Well, you want to find the match index. The index of the match, was it the first one or was it the second one or the third one or the fourth one? You want to find the match index, and that is going to be matches dot. Okay, why is this matches? Because we called it matches here. This match index, we could have called anything. We could have called it kitty box, but we're going to call it match index because that's what we're looking for. So it's going to find where in matches, what is the index where there is a what? A true. Okay, so this is the variable matches. Okay, and then it says if anywhere in matches there's a true. Well, there is a true in matches, so it'll come in here. It'll say match index is equal to, you look at matches and you find the index of where true is. And so this would probably be useful to then just say print match index like that. So now let's run it. And I think this will kind of show you, it'll help you understand what we're doing. This is really pretty easy. Okay, so this one, where was the match? It was in location 1. So location 0 is false, location 1 is true. So yeah, that works. And then here, where was the match? At position 0. And at position 0, there's a true. Okay, so you see, this tells you the position of where the match is. Okay, now if you want to get even snazzier, what you could say is you could print, and what do you want to print? Names of what? Of index. Okay, because the names, if it says names of 0, it'll be Donald Trump, names of 1 will be Nancy Pelosi. So what you can see here is that in this picture, names of index, why does it not like that? Oh, okay, I'm sorry, it wasn't. I didn't use the right. It should have been what we just found, matched index, like that, which is what we found. Now this should actually print the person's name that's in the box, okay? So it looks at the picture and it finds, first of all, it finds Nancy Pelosi in the first box, and then in the second box it finds Donald Trump. Okay, so now we kind of got their name. Now we got to kind of make it a more graphical. Now we know who's who, but now we got to go in and we need to make it more graphical. And so we're going to come out of this, and what we are going to do when we come out of this, we're going to say cv2.put text. Where do we want to put it? Remember the unknown face BGR, because this is an OpenCV command. We got to go back to the BGR version of it. What do we want to label it? We want to label it with the name that we just got. And then where do we want to label it? Well, we want to go left top, because we want to go kind of to the top left of that box that we've already drawn. That box that we have already drawn. I hope we've already drawn it. Yeah, we already drew it. Right up here we drew it. Okay, now we're putting a label on that box. And so top left, and then right bottom, and then what color do we want it? Let's make it blue. Okay, let's make it blue. So that's going to be 255, 0, and I am going to have to get out of your way more here. All right, and then we need to give it a box thickness, and so I'll say the line thickness is about 3. Could it really be that easy? Could it really be that easy? Well, once the whole thing's done, we've stepped through everything. Now we're going to come out of the if statement and out of the for loop. And what we're going to do is cv2.im show. And what do we want to show? Unknown face BGR. And we need to put it in a box. And so my faces, we'll call it like that. All right, so now we're going to do an IM show of this image, and it should have boxes around the face, and it should have them named. Font face is required to be an integer. What on earth is this nonsense? Okay. Oh, I know. I think what I need to do is I need to say the name is equal to the names of the match index. Okay, so I found the position of who it was, but now I need to actually make names of that position. And I did it here, names of match index, but I didn't actually put it in a variable. So now it is in a variable, and now I actually think we should see something here. What is all this nonsense? Okay. Did not like that, did it? Let's see what happened. Okay, input text. Font face. I didn't give it a font name in here somewhere. Somewhere in here it wanted font. Is it after name? Yeah. Font. Okay, after the location. After the location, now I need to give it a font. And then I need to give it a font scale. I'll say 0.5. And then after the color, I need to give it a weight, which I would say would be, let's give it a 2. Okay, 0.5 is a small font and 2 is kind of a heavy font. So let's try this now. Still not happy. Okay, let's see. I've got font, I've got comma 0.5, I've got comma 25500. I've got 2. Where is my mistake? Unknown face BGR name, and then I've got left top, and I got right bottom. I got font. Did I give it a font up here? Yes, I gave it a font. 0.5. Do you guys see my mistake? I am having trouble here. Font face is required to be an integer, which is really, really confusing to me. Font CV2, font Hershey Simplex. That looks good. Folding up like a cheap lawn chair here live. Unknown face BGR. Name, left top, right bottom, font 0.5. Wow, that sure looks right. Let me cheat a little bit here. Yes. I'm sorry. I was using, the whole thing is I was thinking about rectangle. You just do the top left of where you want to put the text. You don't describe 2 points. Rookie mistake. And we wait in anticipation. Boom! Look at that. Donald Trump and Nancy Pelosi. And I don't like that at all. So I'm going to come over here and I'm going to change the text to red. So it's going to be 0 blue, 0 green, and 255. And that text needs to be a little bit taller. So I'm going to say 0.75. And now we are going to run this thing. Okay. Donald Trump and Nancy Pelosi. Boom. Okay, boom. Let me just see here. What if I cheat a little bit? I'm going to cheat a little bit by looking at those images and see if I can do another unknown. Let's do up here. Let's try U1 and see what happens. So I'm going to just change. Could you guys see what I did? U1 up here. So I'm loading a different image, and let's see what happens this time. Okay, this time there is 1, 2, 3, 4 people. It says this. Let me make that longer so we can look at it a little longer. 10,000. Okay. Okay. Pence is unknown. You've got Donald Trump is known. This guy's unknown, and this guy's unknown. So it recognized in this group of Donald Trump, and it says everyone else is unknown. Well, Pence, let's see if we can teach it Pence. So I'm going to get the Pelosi code, and I'm going to copy it, and then I'm going to come here, and then I'm going to say Pence face, 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 like that. And then here I need to train it who, and I got to make sure I get the spelling right, Mike Pence, M-I-K-E. So I'm going to get that, and I'm going to train it on another one. Okay, so now I've got Pence face encode, and so what I need to do here is Pence face encode. So I need to add that, and then I need to add his name to the list, Mike Pence, like that. And now let's run. Now let's see if it can find him, because I've trained on him. I didn't train from that picture. I just trained on a random person. Shazam. I got to make myself bigger. Who's your Huckleberry? Yep, look at that. We found him. We trained it on Mike Pence, and then we found Mike Pence. And let's see what the picture looked like that we trained on. So you see it found in Mike Pence, Don Trump, still doesn't know who those two people are. So now let's see here exactly what that looked like. And so I'm going to look at the demo images. I'm going to look at the known. Okay, I'm going to look at the view extra large icons. And it's not wanting to show me those. Let's see. It's not showing me the thumbnails. These are the knowns. I guess I can just click him open. Mike Pence. We'll just see what the picture looked like that we trained on. There it is. Okay, there's the picture we trained on. It's just a straight frontal portrait of him, and then it found him in our other. It found him in our other image, and it was quite a bit different, you see. But it learned who he was, and then it found him in a crowd. There, you see, there he is. Found him in a crowd. Okay, guys, this is pretty slick. So, what you can do is, and then I'll give you your homework. First of all, I went over a lot of stuff. I really explained how these data sets work. You might need to go back and watch this video again to just really understand again what these zeros are, why sometimes I used a zero and sometimes I didn't to pull that data out of the array that it was in. What you can do is you can play around with these known images, and then you can come and you can play with the unknown images. The other thing that you can do is you can pick these known people. You can go to YouTube and you can play a video, like let's say one of the president's, the former president's news conferences where he was there with the Surgeon General, was there with Dr. Birx and all of those, and you can just see it finding those people that it's trained on in the press conference, and that is pretty cool. Okay, so this is your assignment for, so get familiar with it. Play with your known faces and your unknown faces and get comfortable with this. It's just like 40 lines of code, so it's not that complicated, but get really comfortable with how this is working. And then what your homework is for next week is to have a training set. And it would be great, like if you did the training set with the people in your household. So like train it on the people in your household and then run your webcam and then have it live, recognize people running your webcam live. And so as people are moving around, it's tracking them in the box and that label is staying on their face. So tracking, doing real time face recognition on live video in real time and maintaining the tracking and identification of who's who. That is your homework. It would also be interesting for you guys to instrument your code so you could sort of see that you are able to do face recognition at how many frames per second. And kind of depending on your computer, this might really slow some of you guys down. If you have an older computer and not much graphics processing capability, it might go like a frame a second or something like that. And some of you with more processing power should be able to do significantly faster than that. But that's your assignment, is to do it on live video. Okay, guys, I really hope that you are having as much fun taking this as I am making it. And I love it when you guys post your videos on YouTube. When you do that, please, please, please put a link back to this lesson so anyone who just happens onto your video is going to have context that you're giving the homework solution to this lesson. So I would really appreciate a link back to here. And then I go and I enjoy looking at your homework assignments. I also enjoy it when you guys watch each other. So look in the comments down below for people who are posting their homework solution solutions. Go and see how they did it. Did they do it like you did it? Did they do it differently? How does that work? Okay, guys, we are really getting into artificial intelligence here. I'm still toying with the idea of sort of branching off into some hardware stuff where maybe we mount the webcam on a pan tilt servo control bracket and then actually move the camera where, like you could imagine, having an object of interest or something of interest and then have the camera track that object of interest. So I kind of think it would be fun to branch off in that area at some point, and I'm kind of toying with the idea. Continue to leave me feedback if you think that would be a good idea. Okay, guys, this is Paul McWhorter from TopTechBoy.com. If you enjoyed this video, be sure to give us a thumbs up. If you've not already, subscribe to the channel. When you subscribe, make sure you ring that bell so you will get notifications of future lessons. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.